Okay, we're going to go through some questions for the prologue chapter, some review questions just to test your understanding, your basic peripheral understanding of this chapter. So let's look at question number 1. Constellations appear to move across the sky at night because A. The Earth orbits the Sun, B. The Moon orbits the Earth, C. Stars are in constant motion, D. The Sun orbits the Earth, E. The Earth spins on its axis. I'm reading all the answers so that gives you some time to think about it. Constellations appear to move across the sky at night because, well, that's the appearance to us that the constellations are moving from east to west across the sky every night. But the real reason is not because the sky is moving, but because we are moving. Because the Earth is rotating on its axis towards the east, that makes the sky appear to rotate towards the west. Hence, it's not due to the Earth's orbit or the Moon's orbit, but indeed it is the Earth spinning on its own axis that causes the sky to move every day. The Sun, Moon, planets, and stars all rise and set because our planet rotates once each day. Question 2. What causes Earth's seasons? A. The wobble of the Earth's rotation axis, B. The greenhouse effect, C. 23.5 degree tilt of Earth's rotational axis, D. The movement of Earth closer to or further from the Sun, E. Global warming and cooling. Well, the Earth has been having seasons much longer than the global warming and cooling or the greenhouse effect in different degrees. What truly causes the Earth's seasons is the changing of the intensity of the Sun's light on the Earth. If the Earth is tilted towards that light, then you get the full brunt of that light, so you get the same energy over a smaller area. Hence, that would result in the summer season. And if the Earth were tilted away from that light gets distributed over more surface area of the Earth, hence decreasing the intensity of that light, that radiation, and hence you would have the winter season. So it's the Earth's tilt that determines the seasons of the Earth and not really the other factors. In fact, the Earth is closer to the Sun in January, so the location of the Earth is less important. So our planet's tilt and not its changing distance from the Sun is what creates our seasons. Question 3. What is the path that the Sun, Moon, and planets follow through the constellations? A. The celestial equator, B. The North Celestial Pole, C. The Milky Way, D. The zodiac, E. The ecliptic. Well, A. The celestial equator is just a projection of the Earth's equator onto the sky. That has no correlation with the Sun, the Moon, and the planets. Neither would the North Celestial Pole. The Milky Way is just our galaxy in the sky. Again, that would have no necessary significance with our solar system. But the ecliptic is the path that the Sun appears to move in our sky. In other words, the ecliptic is the plane of the solar system, and within plus or minus 30 degrees of that plane, for reasons that we'll explain later, all the planets reside, including the Moon as well. So the Moon, the planets, the Sun, all are within plus or minus 30 of one plane, the ecliptic plane. And to our vantage point, to our observance, the Sun is following that plane, which looks like a line across the sky. So the path of the Sun, the Moon, and the planets seem to follow through within plus or minus 30 degrees is the ecliptic line in the sky. they do pass through the constellations of the zodiac, but that's not exactly what is being asked here in this question. So the ecliptic marks the plane of the Earth's orbit around the Sun, marks the plane of the solar system. Question 4. How long does it take the Sun to complete one circuit of the ecliptic? Well, again, the appearance of the Sun going across this line in the sky is more due to our motion around the Sun rather than the Sun's motion to us. So it appears to follow this motion because we are revolving around the Sun, and hence, in relation to the full sky, from our vantage point, the Sun will make one revolution across the sky in the time that we take one revolution around the Sun. Hence, the Sun will take one Earth year to complete this revolution around the sky, path across the ecliptic, through the 12 constellations of the zodiac, the 12 months of the year. Question 5. How long does it take the moon to go around the ecliptic? A, 1 day, B, 1 hour, C, 1 week, D, 1 month, E, 1 year. Well, the planets and the Sun and the moon are traveling basically within this plane, near this line of the ecliptic, but the moon is traveling around the Earth, and it takes 1 month for the moon to travel around the Earth. From our perspective, then it would travel across the celestial sphere over the course of this month. It would seem to travel on its own rate across this background of stars. Hence, the moon's time around the ecliptic is indeed 1 month. Question 6. Stars in a constellation are A, physically close to each other, B, usually equal in brightness, C, about the same age, D, about the same distance away, E, in the same part of the sky. Let's look at this one in sequence here. A, physically close to each other. We know that they appear to be close to each other just from the two-dimensional image that we see on the sky, but in reality the stars could be hundreds of thousands of light years apart, and in fact and of different brightnesses, so they just appear to us in a two-dimensional image to be close, but they're actually in distance most likely very far apart. B, usually equal in brightness. No, different stars in the constellation can have different brightnesses. Truly, if you want to see the full influence of a constellation, you would want to go to where the sky was dark somewhere and look at the sky there, so you could see all the different stars are included in that constellation, and you would find that there are bright stars and there are dimmer stars that make up these images, and probably give you more significance to why people thought they looked like the figures that they look like. So they're not usually equal in brightness. C, about the same age. Now the stars are being formed and were formed at different times in the progression of the universe. So not necessarily the same age. D, about the same distance away. Now we already said now they could be far apart from each other. So E, in the same part of the sky, I mean, visually that's all we can say, is we look out into the sky and we see a constellation there, and they appear to be in the same part of the sky as we see it, even though they're not in the same part of the universe. So stars within a constellation might be very different distances, ages, types, and brightnesses, but we see them in the same part of the sky. Question 7. The vernal equinox marks the beginning of A, summer, B, fall, C, winter, D, spring. Well, the vernal equinox is the point in the sky at which the sun, in its path across its journey along the ecliptic, seems to pass from south of the celestial equator to north of the celestial equator. So as it crosses the celestial equator, that is what marks the vernal equinox. That occurs when we go from winter season into spring, and hence it occurs at the beginning of spring, right around March 21st or 22nd. Question 8. The angle of parallax increases as A. The distances to stars increase, B. The baseline gets larger, C. The baseline gets smaller, D. The Earth moves faster in its orbit. Well, parallax is the apparent change in position of something with respect to something that's further away, and you can recognize this as you look at a closer object with respect to a further away object. And so if the distances to the stars were to increase, the angle of parallax would get smaller. It'd be harder to discern that distance. As the baseline got larger, you'd be able to see more of that shift of a near object with the distance objects. So our answer here is that the baseline gets larger. The greater distance between two observation points, the larger the angle of parallax. We knew it was either B or C because they're exact opposites of each other, so we chose B. Question 9. Precession is caused by A. The rotation of Earth's molten core, B. The gravitational pull of the sun, C. The gravitational pull of the moon, D. The weight of ice at the poles, E. Gravitational attractions from comets. Well, all these things have an effect on the motion of the Earth to different degrees. Precession is a definite movement of the Earth over the course of 26,000 years, but the thing of this list that has the most gravitational influence on us is the moon. The sun obviously is keeping us in orbit, has a great gravitational influence on us, but this is more of a tidal, a differential gravity type effect due to the location of the moon. The moon keeps us in this rotation, or in this revolution of precession, and actually it's a very good stabilizing effect to us. So the answer to this one is the gravitational pull of the moon. Well, if you've done very well in this quiz, then you probably are in good shape going into the questions, but you want to look at all the questions that are in the questions for this chapter. You want to look at all of them and answer them all to get you ready for the first quiz.